Okay, so welcome back, and in this video we're going to be looking at core practical 6, which is the bromination of butan-1-ol. This is one of the largest practicals you would do in the lower 6th. It involves some quite hazardous chemicals like concentrated sulfuric acid, and it generates a little bit of bromine as well. So I'm going to talk through the experiment and then we're going to answer some questions about it. Okay, so we're looking at page 5 of your notes, and obviously sadly we can't do this experiment, but I am going to take you through it and you're going to watch some videos about it and we're going to do some questions on it. So you should see this diagram to the side of page 5. The X's stand for where we clamp it, and then we would cover the pear-shaped flask with ice and water to keep it cold. It's important the first step of this reaction is done under cold conditions. Then in the pear-shaped flask we're going to put our butan-1-ol, some potassium bromide, some water and some anti-bumping granules. The anti-bumping granules are there to promote smooth boiling. In the tap funnel at the top we have 10 centimetres cubed of concentrated sulfuric acid. Okay, so before we move on, you're going to have to watch a couple of videos about the preparation of bromobutane. These are both given to you in the PowerPoint on GOL, so you need to watch. I would advise both of those before you move on. Then have a go at the questions on the next page, on page 6, and we'll go through those in detail when you've had a go at doing those. Okay, so we're now at the top of page 6 and we're looking at those questions. Hopefully you've had a look at the videos by now and they will have taken you through the practical. And you'll have a go at the questions. I'm just going to go through them with you. So first of all, the reaction between concentrated sulfuric acid and sodium bromide. This is one you've come across before in your halogens pack. So the first step is to produce the hydrogen bromide. Then we're asked, why is it necessary to add the concentrated acid slowly? Well, hydrogen bromide is also a good reducing agent, and it can reduce the sulfur from the +6 oxidation state in sulfuric acid to the +4 oxidation state in SO2, releasing some bromine gas. Now we want the hydrogen bromide to react with that alcohol. If it's busy reacting with the sulfuric acid, it won't be available to react with the alcohol. And another point, bromine gas is particularly nasty, toxic and corrosive, so making more of that is not a good idea. There's a tube with a side arm between the condenser and the top funnel, because even though we're cooling this, there are some gases that possibly are being produced, and we don't want this to be a closed system. Anytime you've got gases being produced, you don't want a closed system. So that's why there's a side arm between the condenser and the tap funnel, so that we don't build up any pressure. As you proceed during the reaction, you should see the steamy fumes. These are hydrogen bromide, and you should see the orange fumes of bromine being produced. So the steamy fumes of HBr, possibly looking at some SO2, and the orange fumes of bromine. So yes, we expect to see bromine and sulfur dioxide and hydrogen bromide. Bromine and sulfur dioxide are side reactions, so we don't necessarily want those, but we definitely want the HBr. Okay, in terms of why we heat under reflux, what happens here is our heated solution evaporates, rises up the vertical condenser, condenses on the cold wall of the condenser and drops back down into the vessel. This avoids any flammable toxic gases being released into the lab. It also allows a longer reaction time with no loss of contents. It allows us to heat the mixture and keep it in contact for a long period of time, and that's very important when we're reacting organic reactions. They tend to be quite slow, they tend to have high activation energies. So we have a guard tube on the side of our apparatus during the refluxing stage. This contains soda lime, and this reacts with any acidic gases like HBr and prevents them from being released into the lab. It also will absorb any bromine gas which is being absorbed. Usually we don't need one of those, but HBr and bromine are both dangerous and very difficult to actually stop them from escaping. So that's what the guard tube is just there for. Normally when we're heating under reflux, we don't include a guard tube. Why is it necessary to heat the flask for such a long time? We've kind of covered this already. So I've got the old answer copy. So we usually say because the reaction is slow or has a high activation energy, call it EA. So reaction needs heating and in contact. So we need to be able to heat our mixture and keep it in contact for a long period of time. And that's because that reaction that we want is very slow. It does let us to get a higher yield, to get the reaction as complete as possible. But remember, this is an organic reaction, so it's unlikely to go to completion. There's likely to be side reactions and other things going on as well. Okay, so we're going to go on and look at separation of the product. So we're on page 7. So we've carried out our reaction. In other words, we've heated it under reflux for about half an hour. So this is carrying out the reaction. So this is heating under reflux. Remember we said that we need to heat it for a long period of time because it's got such a high activation energy. Next we need to do a simple distillation. And all this is going to do is it's going to distill off the impure product. So we're going to do simple distillation. And this will just pull off the impure product at this stage. The next step, purification of the product. This comes in various steps. So the first step here is extraction with a solvent, and I'll go on and look at that in a little bit more detail in the next video. So extraction with a solvent using a separation or separating funnel. That's what one of these things are, and I'll have a look at that in the next video as well. Now we've got our product separated. The next thing we're going to do here with it is we're going to dry it. So this is drying the product, usually with a drying agent like anhydrous sodium sulfate. The last step in the purification is the final distillation. And to check the purity, we can measure the boiling points of our components. Okay, now there are several questions on this, and as I said in the video, this is an organic reaction, so there are lots of other reactions going on, side reactions, unwanted products that tend to be formed. So these are some of the impurities that could be left after the initial stage of heating under reflux. So they can be leftover sodium bromide, that's one of our starting materials. There could be sodium hydrogen sulfate, that's formed during the reaction, from the reaction between the sodium bromide and the concentrated sulfuric acid, which again is a starting material. The butan-1-ol, again, is a starting reaction. Hydrogen bromide is formed during the reaction, and bromine is one of our side reactions. So what impurities are left in the mixture after the first distillation? Well, you'll see a little bit later on, or you might have seen already in the video, that you get two layers. You get an aqueous layer and an organic layer. So we're going to look at both in part. So the aqueous layer will contain the sulfuric acid and the hydrogen bromides and water, because we added water, if you remember, at the beginning. The organic layer will contain my butan-1-ol, some bromine, possibly some other organics like butene or butoxybutane, from some side reactions, as well as the organic compound we want, which is our 1-bromobutane. So as you can see, this is a multi-step reaction, a multi-step procedure. Okay, so that just finishes this video, just looking at the preparation of 1-bromobutane from butan-1-ol. And we've started to look at the next stages in the preparation, which would be the purification of the product once we've formed it by heating it under reflux for about half an hour. So this is, as I said, one of your core practicals. So that core practical would have taken you about a double lesson, and then we would have taken the next double lesson to do the purification steps. So in the next video, we'll look at those in a little bit more detail. But till then, take care, stay safe. Bye-bye.